everybody, we're back with section 9.5 on inscribed angles. Before we talked about central angles, so now we'll see what an inscribed angle is and what its measure is. So an inscribed angle, here's the definition. It's an angle whose vertex is on the circumference of the circle and whose sides contain chords of the circle. So right here you can see, here the vertex is on the circumference and this side of the angle CD is a chord and AD is a chord. So this right here is an inscribed angle. So name an inscribed angle. Well, I just did that. It's angle ADC. So why is DAB not an inscribed angle? Or why is DCB not an inscribed angle? So think about that, and hopefully you know that answer based on the definition. Number two, we're going to use a protractor to measure the central angle. So go ahead if you want to pause. Go ahead and do that, or you can get a protractor. I'm sure you have one at home, right? Those are going to line up very well. And then we're going to move that over. So I'm trying to figure out what the measure of the angle is. Oops. Oh wait. Measure of angle ABC. Yeah, good. The central angle here. So remember, ABC is the central angle. So here we have it. So it looks like this. Oopsie. So I can't really mark it very well, sorry about that. So it looks like it's here, it's going to be about, I don't know, 0 to 100 degrees. I was going to try to write on it, but I can't because this is going to move. So anyway, let me see here. Oh, yeah, make it smaller? No. So it looks like it's about 100 degrees. Now use a protractor to measure the inscribed angle, so I'm going to move this down here. Change my thing slightly. And it should be about 50 degrees. Let's see, I can't quite get it measured out. But I'm going to go 50 degrees because I know that's what it's supposed to be. Maybe you were a little more accurate because you don't have the tools on the Promethean like I do where I can't get it very accurate. So how do these two measures relate to each other? And that will help you answer the question. So the measure of an inscribed angle is equal to half the measure of its intercepted arc. So angle ADC and angle ABC, how do these measurements equal each other? Well, the measure of ADC is half the measure of angle ABC. So mathematically, that's what that would look like. Okay, so let's move on. The measure of angle ABC. So we need to measure this, angle ABC, that's an inscribed angle. Then we're going to measure angle ADC. That's also an inscribed angle. Compare angles ABC and ADC. Make a list of some similarities. So what do you notice? So maybe you notice that both of them end at A. They have a chord that goes to A and a chord that goes to C. So they have common points that they intersect around the circle. Maybe you notice that they are both inscribed circles. So both of their vertices are on the circumference of the circle. So therefore, when you measured them, what should be true? It should have been true that those two measures were congruent to each other. So the measure of angle ABC is congruent to the measure of angle CDA because they both open to this arc. And remember, the arc measure is the same as the central angle. If we made the center of the circle, well, this would be the central angle, and then these two inscribed angles would be half of that measure. So if they open to the same arc, that means they have to be the same angle measure. So fill in the theorem, or the corollary. If two inscribed angles intersect the same arc, then the angles are congruent. So angle ABC, in this case, is congruent to angle CDA. Okay, let's move on. So here we have arc ABC. So arc ABC, well, what do you notice about this arc? Well, here I can see that AC is a specific type of chord that goes through the center of the circle. And a specific type of chord that goes through the center of a circle is called a diameter. So AC is a diameter. And if AC is a diameter, that means that ABC, arc ABC, is a semicircle. So arc ABC is a semicircle. Well, if arc ABC is a semicircle, then what does the measure of angle ABC equal? Well, we just learned back here, right, on this previous page, we learned that an inscribed angle is half the measure of its intercepted arc. So an inscribed angle is half the measure of its intercepted arc. Well, here's an inscribed angle. ABC is an inscribed angle, so therefore it must be half the measure of its intercepted arc. Well, if the red arc is a semicircle, that means that the other side, this green arc, must also be a semicircle. So a semicircle, we said, is 180 degrees, right? It's half a circle. One circle is 360, so a semicircle is 180. So therefore, the measure of angle ABC needs to be half of 180. And we know that that is 90 degrees. So this should say the measure of angle ABC is equal to 90 degrees. If you're not sure, you can take your protractor and you can check it out. Oops, I need to rotate it the other way. And there we see it comes out to 90 degrees, so that is correct. In inscribed angles, let's complete the corollary. An inscribed angle in a semicircle is a what angle? Is a right angle, an angle that is 90 degrees. Okay, moving on. Use this circle to draw any type of inscribed quadrilateral. Measure its opposite angles. What do you notice? So I'm going to let you, go ahead and do this on your own. So pause, figure it out, and then check your corollary when you're finished. Okay, so you should have done the activity. You could have drawn any type of quadrilateral in here, hoping you wouldn't draw a special quadrilateral, meaning no isosceles trapezoid or no square, something like that. So here I have a quadrilateral. My angles are all different. But this says measure the opposite angles. So what do I notice about my opposite angles? So they add up to 180 degrees, or yours should have been really close, right? So both sets of opposite angles should add up to 180 degrees or really, really close, depending on your slight error in measuring. So let's complete the corollary. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So there we have it. The opposite angles are supplementary in an inscribed polygon, or specifically a quadrilateral. Here I'm going to go ahead and let you try investigation 5 on your own. So read through this, and then you should be able to also fill out these blanks on your own once you read that. If you have questions about it, please ask me in class. Okay, I'm assuming that you don't have questions if you don't ask me in class. I'm assuming that you understand everything you've read. Okay, now it's time to go through these practice problems. Again, I recommend you push pause, do all the problems, and then check your answers with me when you are done. So go ahead and push pause now. Okay, so here are the answers. Just check right now. If you need more time to check, then pause your computer, remember, before you scroll down. So you can pause now. Or continue because you got them all right. So here are the final answers. Hope you did well. Ask me questions in class if you didn't get it. See you soon.